In this section, let's start diving into these mechanisms in the endocrine system, especially this most important one, which is the relationship between the hypothalamus and the pituitary gland. The hypothalamus is this portion in the middle of the brain, and the pituitary gland is this two-part gland that hangs down from it. Actually sits in its own little pocket of bone, which we learned about in the skeletal system. The hypothalamus sends signals to the anterior pituitary that make it either increase or decrease the secretions of hormones from the anterior pituitary. The hypothalamus also makes certain hormones, antidiuretic hormones and oxytocin, that are directly stored from the posterior pituitary and then released from there. So the posterior pituitary is actually an extension of the hypothalamus. Okay, we're going to focus on this anterior pituitary and one of the hormones it produces, which is growth hormone. But first, here's the hypothalamus talking to the pituitary gland in another awkward Yeti cartoon. And the hypothalamus says, "You wield great power, pituitary. Use it wisely. Go now, release the hormone armies and bring balance to the realm." And the little tiny pituitary says, "Squeak." Go. Squeak. Because the pituitary really is very, very tiny, although it does have huge power over the body. Now, growth hormone does exactly what you think it would do, makes things grow. It's actually released all through your life by the anterior pituitary gland. Growth hormone is what we call an anabolic molecule, meaning that it builds up other molecules. So it gives a signal for the cells in the body to increase their production and make larger molecules. It's very important for bone growth and muscle growth and things like that. During childhood, it actually has to be combined with hormones from other parts of the body, including thyroid hormone, which we'll come to in a minute, insulin from the pancreas, sex hormones, in order for certain tissues to grow normally. In adults, growth hormone stimulates the release of other hormones called insulin-like growth factors that you need to stimulate bone and other soft tissue growth, including muscles. If you don't have those, then your bones won't repair normally. You won't be able to heal soft tissue normally, and you won't be able to build up, for example, muscle tissue. So it's really a very, very important hormone, but it's important at all stages of life to have the right amount of it. Getting too little or too much can be a huge problem. The most common way that dysfunction happens in the pituitary is a tumor on the pituitary gland. Because the pituitary sits in a little pocket of bone, there's nowhere for the pituitary to expand if there's extra growth. And so a tumor ends up pushing on some cells and essentially causing those cells to release excess hormone or preventing them from releasing hormone. One pathology that used to be common and is not seen very often anymore is a lack of growth hormone. And this could be just because the cells in the anterior pituitary don't produce growth hormone with or without a tumor. This is one of many possible causes of dwarfism, but it is not seen very often any longer. So you can see in this picture, this is a fully grown woman standing next to a normal-sized chair. So she's obviously very, very small, but if you didn't see her next to the chair, you wouldn't necessarily think that she was a dwarf because all of her parts are in proportion. This is a classic sign of pituitary dwarfism, in which all of the tissues get the same amount of growth hormone, but too little. So they grow in normal proportions, but not big enough, not tall enough for normal growth. This form of dwarfism is uncommon today because it's very easy to give growth hormone to a child that is not growing sufficiently. A more common form that we see today is achondroplastic dwarfism. And we talk about this when we talked about the skeletal system. what happens in achondroplastic dwarfism is that cartilage tissue doesn't develop normally. Bones that depend on cartilage for growth don't develop normally. And so we see a normal-sized head and very short arms and legs. The long bones don't grow correctly, but the bones of the head do. So this is an entirely different one, and we'll come back to this when we do the skeletal system. The opposite of pituitary dwarfism is a condition called acromegaly, which is a result of too much growth hormone. And the most common cause of this is a tumor on the pituitary gland. The common features of acromegaly are a very long and square jaw, excessive height, especially very long hands and feet. This is a picture of Robert Wadlow, the tallest human who ever lived, who grew to be 8'11", and his record of height has still never been broken. So this is him next to a car from the 1940s, and two young ladies who are obviously of fairly average height, and one doesn't even come up to his waist. Acromegaly can also develop during adulthood. Robert Wadlow had acromegaly his whole life, and so he was over 5 feet tall at age 5. He was just a huge human, a very tall human his whole life. If a person has acromegaly, not during childhood, but only during adulthood, they will grow normally, and then the bones, especially of the hands and the face, continue to grow. And so later in life, a person can develop this very square chin, long face, and long hands. This is actually the same woman at age 16, age 33, and then at age 52. So this is an example of acromegaly during adulthood. A very famous person with acromegaly was Andre the Giant. So if you follow this scene, you will see Andre the Giant in the best movie ever made, The Princess Bride. I'll let you watch that on your own. And then in our next section, we're going to talk about all the other organs and glands in the endocrine system and what their functions are.